Okay, you know the drill. Every 4 years, the Winter Olympics roll around, and we all rediscover this sport that, let's be honest, seems a little weird. You've got people sliding these giant stones down the ice while two others are just sweeping like crazy in front of it. And for a lot of folks, the reaction is pretty much the same.
Yeah, exactly. It becomes this running joke, right? The quirky sport with the brooms and all the yelling. It looks so simple, maybe even a little bit silly. But what if I told you that that reaction is completely, totally missing the point? Because hiding just underneath that seemingly simple sheet of ice is an incredible story. We're talking million-year-old geology, a tech doping scandal that actually rocked the sport, and a physics mystery that has had scientists scratching their heads for over 100 years. So in this explainer, we're going to look a little closer.
To really get what's going on here, we have to get the basics down first. Because, trust me, there is so much more happening than just sliding some rocks around. So, the game itself is pretty straightforward. You've got a team of 4, and they're sliding this nearly 20-kilogram granite stone down the ice. The goal? Get it as close as you can to the center of that target, which they call the button. Whichever team has the closest stone at the end of a round scores. Simple, right? But the foundation of the game isn't just about the rules. It's about a code of conduct.
This is what makes curling so different from pretty much any other professional sport out there. I mean, even at the Olympic level, players call their own fouls. You're actually expected to compliment your opponent when they make a great shot. And after the game, tradition says the winners buy the losers a drink. It's this deep-rooted sense of sportsmanship that really sets the stage for everything else.
But this isn't just about being polite. The game's complexity goes way deep into strategy and the equipment itself. There's a reason people call it chess on ice, and a big part of that reason starts with those famous stones.
So, this is how much a full set of 16 Olympic-grade curling stones will set you back. That's more than $600 a pop. And when you see a price tag like that, you have to ask, why on earth is a chunk of granite so expensive? Well, it turns out it's not just any granite, not by a long shot.
Get this. Every single Olympic curling stone comes from one tiny, uninhabited volcanic island off the coast of Scotland. It's called Ailsa Craig. About 60 million years ago, a totally unique magma eruption created this granite with a chemical makeup found nowhere else on the planet. It's incredibly dense, so it doesn't absorb water and doesn't crack, making it absolutely perfect for gliding on ice. But the stone is only half the story. The other half is the ice.
Yeah, if you were to get down on your hands and knees and look at a curling sheet, you'd see it's not smooth like a hockey rink. It's actually covered in these tiny frozen droplets. It's a texture called pebbling. This little trick reduces the amount of stone touching the ice, which lets it glide farther and more consistently. And it's this pebbled surface that brings us to all that sweeping. That sweeping is not just for show. It is a critical part of the game. In fact, and this is wild, it's the only Olympic sport where the players can actually change an object's path after it's been released. All that frantic sweeping melts the tops of those little pebbles, creating this super thin layer of water. That little bit of lubrication can make a stone go up to 3 meters farther. But it can also influence the direction it travels, which a few years ago became the center of a huge controversy. Now, the technology behind a broom seems pretty simple, right? But back in 2015, a new innovation came along that threatened to completely break the sport. These new brooms hit the market with this special directional fabric. It was so good at scratching and manipulating the ice that players started calling them joysticks. You could basically steer the stone wherever you wanted it to go, even if it was a terrible throw. And this totally violated that spirit of curling. So, and this is the amazing part, 22 of the world's best teams made a pact to ban the brooms themselves before there were even any official rules against them. It just shows how much they cared about the balance of skill in their sport. Yeah, the whole point of sweeping is to make a good shot great, not to turn a totally botched shot into a perfect one. This new tech was overpowering human skill, and the players themselves had to step up to save the soul of their game. But while they managed to solve that problem, a much, much deeper one has stuck around for over a century. This is where curling goes from just being a fascinating sport to a legitimate scientific puzzle, one that actually challenges our basic understanding of how friction works. Okay, check this out. In our normal world, if you slide something that's spinning forward, like say a glass on a table, friction is higher at the front of the object. This slows the front down and it makes the object curl against its spin. so a clockwise spin should make it curl to the left. But curling stones do the complete opposite. A stone spinning clockwise curls clockwise, to the right. And for 100 years, nobody has been able to say for sure why.
So the first logical guess was that the sheer pressure of that heavy stone melts the ice in front of it. That would create a little layer of water, meaning less friction in the front and more friction in the back, causing it to curl with its spin. It's a really clean theory, but yeah, it was wrong. Scientists looked into it and found that the stone just doesn't spin fast enough or press down hard enough to create the amount of water you'd need to explain that big, sweeping curl. So it was back to the drawing board.
Okay, so the next theory was even more clever. It suggested that the bottom of the stone, which is a little rough, actually carves tiny microscopic scratches into those ice pebbles. So as the stone spins clockwise, the front edge would make these little grooves that would then guide the back of the stone to the right, basically steering it in the direction of the spin.
And this one also sounded great, but it didn't quite hold up either. While the stone for sure makes scratches, the researchers figured out they were just too tiny on their own to have that powerful of an effect. Which brings us to the current and I think the most fascinating theory of all.
Imagine running your finger over the teeth of a comb. You know how they bend and then snap back? The stick-slip theory says something just like that is happening on a microscopic level. As the stone moves, its leading edge momentarily sticks to a pebble, pulling it a tiny bit forward and sideways. Then the pebble slips, snapping back into place. This stick and slip action happens thousands of times a second, and it's enough to pivot that massive stone in the direction it's spinning. It is the leading theory, but the mystery is still not officially solved.
So right about now, you might be thinking, wow, that is a lot of scientific brainpower for a game. But it turns out that solving this weird little paradox has huge implications, far, far beyond the curling rink. This all falls under a field of science called tribology, which is basically the science of rubbing and friction. If we can figure out the weird physics of a curling stone, it could help us understand how giant glaciers slide across the land, or even help us design better, safer tires for driving on icy roads. And my personal favorite, it could help us build robots that can drill through the miles-thick ice shells of moons like Europa and Enceladus in our search for alien life. Seriously. In the end, curling is just this perfect example of how the most amazing things are often hiding in plain sight. Something that seems simple or even a little funny on the surface can be packed with incredible complexity, history, and even a genuine scientific mystery. It's just a great reminder that curiosity is an amazing thing. You just have to be willing to look a little closer.